such as coordination of vehicles, synchronization of spacecraft, and formation flights. As one of the most fundamental problems in cooperative control, the synchronization problem has been extensively studied. First, the synchronization problem is studied for homogeneous linear multi-agent system. In particular, research has evolved from some simple dynamics such as single integrator, double integrator, harmonic oscillator to general linear systems. Then, the output synchronization problem of heterogeneous linear multi-agent system is first studied. Here are two representative work in this aspect. In particular, the work by Wieland in 2011 studies the multi-input, multi-output linear system and dynamic communication networks. The similar problem is studied in this reference for single input, single output, and minimal phase linear uncertain system with static communication network. In the following slides, I will give the figures to show the structure of the controller in these two references in detail. This figure shows the structure of the controller by Wieland in 2011. So we can find for each agent, the controller is composed of two parts. The first part is an observer to estimate the system state, and the second part is the reference generator to produce the synchronized signal. The advantage of this controller is that by using this controller, the synchronization problem can be solved in a two-step approach. The step one is to achieve the synchronization of all reference generators, and the second step is to regulate each system's output to the output of its own reference generator. We also find this controller depends on the relative internal states. However, sometimes it may not be desirable to establish the communication channels to exchange internal states. This figure shows the structure of the controller by Key in 2011. So from this figure, we can find for each agent, the controller is composed of three parts. The first part is an observer to estimate the system state, and the second part is a reference generator to produce the synchronized signal for each agent. And the third part is a dynamic compensator for auxiliary stabilization. The salient feature of this controller, we can find it is a purely output-based controller and does not require the establishment of communication channels to exchange internal states. Thus, in some cases, it facilitates the implementation of this controller. However, as I mentioned before, this reference only considers single input, single output, and minimal phase linear system. How to design an output-based controller to solve the output synchronization problem of heterogeneous, generally multi-input, multi-output linear multi-agent system is still an open problem. Thus, in this talk, we study the synchronization problem of heterogeneous linear multi-agent system. In particular, the general multi-input, multi-output linear multi-agent system is studied. The purely output-based distributed controller is constructed. It requires neither communication of internal state nor additional dynamic compensator, which not only reduce the dimension of the controller, but also facilitate the implementation of the controller. Having introduced the background and the most related existing works, now we move to the problem formulation section. In this work, we consider heterogeneous linear multi-agent system of form 1. Without loss of generality, we assume this system is stabilizable and detectable. Associated with this multi-agent system we can define a non-negative matrix, capital O, capital A, where its element aij equals 1, if and only if the controller UI can access the relative state of this heterogeneous multi-agent system. Having defined this matrix capital A, we can use a diagram G to describe the communication network of this multi-agent system by these rules. Furthermore, we can define the Laplacian of the diagram by these rules. Here we only briefly introduce some notation on the diagram to facilitate our talk. More detailed definition can be found in our paper. Now we consider the distributed dynamic outfit controller in form 2, where all these matrices are to be determined. Now we are ready to describe our problem as follows. Consider the heterogeneous linear multi-agent system 1 and the diagram G. Design a distributed controller of the form 2 such that the output of the multi-agent system satisfies this equation. Having our problem well formulated, now I'm ready to present our main result. We introduce a distributed dynamic output fit controller in form 4. The structure of this controller can be seen clearly in this figure. So we can find our controller is composed of 2 parts. The first part is the estimator of the system state to estimate the system state, and the second part is the reference generator to produce the synchronized signal. So from this figure, we can find our controller is a purely output-based controller, and it does not require additional dynamic compensator as in Q in 2011. To solve the problem, we still need these 3 standard assumptions. Assumption 3.1 is to exclude exponentially diverging signals. Assumption 3.2 is a standard assumption of the digraph. Assumption 3.3 requires the linear matrix equations 5 have solution paths xi, ui. Now we can obtain the solution to the output synchronization